Thank you, Sean. Welcome, everyone. Good morning or good afternoon, depending on what part of the world you're logging in from. Um, Today, we have an exciting panel discussion. We got four panelists, and then we're going to be breaking out. But let me go over the high-level overview for you. We're going to be talking about gaps in our curriculum, gaps in the students' learning, maybe even gaps in industry. We lost a year and a half. Well, we didn't really lose it. We had some bumps in the road. So what are the challenges that we face now moving into the fall? Do we have some catching up to do? Are our students ready? What have they learned? What have they not learned? What have we learned? And what kind of resources are available to us? I know industry stepped up quite a bit to help academia out when all the students were remote. Did that work? Did it not work? How are we going to be integrating this with our upcoming year? And could we have done it better? What have we learned from this thing here, not only in academia, but also from an industry side, both our industry partners who have been so helpful for us in helping us through this, but also our end clients, the industry folks that our students are going to be working for. So if any of them are on the call, would love for you all to jump in on the conversation we're going to have. All right, next slide, please. Okay, so the agenda, high-level agenda, we're going to have panelist remarks between now and 10:30. Actually, we're a couple of minutes ahead of schedule here. Then we're going to break out for 40 minutes for our Birds of a Feather breakouts. There's going to be 4 breakout rooms, 1 for each of our panelists. You get 10 minutes in each one of those rooms. And then we're going to come back for the last 20 minutes and do a session wrap up, kind of take a look at all the discussions that we had. The logistics for this particular session, we're going to have the panelists present a very brief topic that they're going to talk about, 1, 2, 3 minutes. They're planting seeds. And hopefully when you get into their breakout rooms, you can continue the discussion. There will be like 4 breakout rooms, 1 for each of our panelists. They will remain in those breakout rooms. The rest of you will rotate between them. You'll be in there for 10 minutes. Our ACETA timekeepers will give us a 2-minute warning when the 10 minutes is almost up. And at the 10 minutes mark, it'll be ding, ding, everybody switch to another room. As John had mentioned earlier, try and level these rooms out. We're not pre-assigning people. So when you go into the breakout room, we've got almost 50 people here. Kind of balance yourselves out and then just switch around to another room. Everyone will get a chance to jump in on each one of them. And then let's see here. I'm going with my other one here. And then when we come back, we'll do a wrap up of the sessions. Also, please be mindful that we do have a lot of people on this call, which is great. Love to see everyone here. So when you're talking, please don't hog the mic. Let everybody get a chance to say something. All right, without further ado, I would love to introduce our panelists. We have Patricia Mendoza from University of Texas at El Paso, Pratap Basappa from Norfolk State University, Alan Feinerman, University of Illinois at Chicago, and Leslie Birch, University of Pennsylvania. So Leslie, I believe you're up. Oh, no, looks like Patricia's up first. Take it away, Patricia.
Hello, good morning. So I want to talk about like what we missed actually during that these remote days. Is like we went from having people around. We have classmates, we have professors around, we got to work together in the same space for projects, and we moved to everything remote. So missing the best resource we all could have, which was people, knocking on doors, asking for questions, having immediate answers, having our friends or classmates working in the same area and same space and talking about like, what is the project, what we couldn't understand in classes, what was going on with, school, university, having all these policies change, like, can we go to the university? Can we be in our lab? Missing resources about having all these lab resources, even the TA, and we have to go to home and do the same lab activities, but without those resources, learning how to build circuits, build equipment, build a lot of lab projects without the experience and probably, being freshmen and barely, starting college without that resource that I love, that, that matches people, they, having people around and how we move. So this is what I consider the most important gap that we have, missing the closeness to people, the, approach to be close to people. Thank you.
Thank you, Pat. Pratap, I believe you're up.
Yes, okay. Good morning or good afternoon, wherever you are. My name is Pratap Basapa. I'm from Norfolk State University. So in this panel discussion, we are going to talk about some of the uh, problems which we encountered during the COVID situation. That is the reason we say that the unmasking the COVID engineer challenges to academia and industry. One of the problems what we have noticed is when, especially in the asynchronous classes where the lectures have been posted and the students go through them and answer them, there is several errors in judgment because it is an unsupervised error. That is unsupervised learning process, because they have nobody to go and ask whenever they find any kind of questions or some kind of uh, mismatch between their understanding and the results which they are getting. And secondly, the most important problem we had was the laboratories, the incomplete awareness of experimentation and learning, especially at different levels. For example, if you take at the introduction to engineering, where they're absolutely unaware of what the things are, what are the laboratory instruments are, the components are, and what is the problem they face and what are its implications. And then the ad hoc learning scenarios, that is the collaboration of the confused, that is X, Y, Z, who are all the participants in the class, they want to collaborate because they're all confused and really are threatened. So they try to get to each other and try to educate between them, and what are the kind of resulting gaps in learning at different levels occur. What I mean is different levels, I mean is at the freshman level, sophomore level, junior level, and the senior level. So if you go back to the taxonomy, the Bloom's taxonomy of remembering, applying, analyzing, synthesizing, and evaluating, so which are basically applied for your ABET accreditation, how does this really affect the students, especially the 1 year of this pandemic, and what is it doing? And then when we are trying to make them as critical thinkers, then the absolute knowing, this is not a difficult thing, especially in the remote learning, but as we go further, the transitional learning, independent knowing, and the contextual learning, that is the ultimate aim for us to, that the students must be able to learn the subject matter and leverage this information base to apply it to different situations so that they could be useful engineers in the workplace. So what can we do in the classroom and in industry to remedy this particular lacuna? So that is what we plan to discuss in my panel.
Thank you, Pratap.
Thank you.
Alan.
Greetings. So the way we handled the pandemic at UIC is, in order to enforce social distancing, we put a webcam on an articulating arm, which you can see with the arrow. And that webcam would look at the student who is present in the lab or the equipment, and we'd have a student or a TA in the lab talking to, on average, 3 students, but as many as 6 students. And in principle, this was a great strategy, but in practice, students really didn't learn how to operate the equipment, and as an experimentalist, I think that's absolutely critical. And so one of the things we're going to be doing is we're going to have, coming up in this fall, we're going to have a one-on-one checkout by the TA to make sure all students can operate all the equipment by the end of the semester. I like to say that our engineering students are very smart, so they know how to maximize their grade and minimize their effort. One of the things we've noticed that the students doing in the labs is that they assign roles, and they're very efficient. So you have one student who's really good at building circuits, another student really good at programming, and et cetera. And that's not what we want. Each student to know how to program, each student to know how to build a circuit and test it. And we're trying to make sure that learning gets down to the granular level. We don't care that just the whole group is performing. We want every student. Thank you.
Thank you, Alan. Leslie.
Hey, hi everyone. So mine are those things that you may be aware that your students are facing or you may not, but I believe that our role in the lab doesn't just stop at the lab. So package deal. These are things that students probably think they come in with and they don't necessarily get all the trimmings. So expenses. When I was younger in college, I didn't have much money for lunch and I was eating noodle cups. You might remember they were in packages in the old days. It might not have even been in a cup. That sort of thing still goes on. Students may have scholarships, but they don't have money to eat. So that's one problem. Another is, what is the tech on hand? This was especially true during COVID, that some of our students had laptops, some did not, some needed those tools. Some didn't have mice because it's popular to have a laptop and not have a mouse. How do you operate your CAD and design software? And finally, and the most important, inclusive atmosphere. In my DEI committee, someone said, you know, what kind of signals is your classroom or lab giving off? Is it worth it for me to be here? Do I even fit in? Or another is, are the professors, are the staff members holding up and keeping to the actual values and codes that are supposed to be within that school? Are they enforcing them? So these are the things I'd like to talk about.
Thank you very much, Leslie. I will leave this to our lovely hosts to tell you how we're going to go into the breakout rooms. I'd love to hear from our panelists. If you can kind of give us a roll up of things that were discussed, things that you had learned, some bullet points to take away. So if we take 5 minutes apiece, we can start off with Patricia.
Hi. So we were talking mostly about students not connecting to other students. For example, we even had freshman students coming to school with, they haven't met, any, professors, any classmates. So how difficult is to start an environment in college and not be able to turn around and say hi, how are you? At least it's I know that person, they don't know anybody. So that's one of the struggles about being in college during this past year for a lot of students. Also, troubleshooting labs, connecting parts and breadboards, connecting doing labs and trying to explain to students, troubleshooting, how to work their labs, how to complete their homework, how to, do all those things remotely. Even one of the professors told us he set up hours in his office with the same setup, so the students, whenever they could come and still have that proximity still with all the care, all the precautions because of the situation, but still have that part about helping the students in person, because it was this situation about trying to explain everything with cameras, students not having even computers. Or what about those students that were overseas and 12 hours difference when we were having a class and a lab and the students were midnight taking classes. And we even I had that situation where I didn't know that I have a student, because the student never told me. Even I asked at the middle of the semester, I realized the student was overseas. So that's difficult. Try to encourage the students to communicate, to ask questions, to ask for help, and for us as professors, even the suppliers, to provide do workshops, help us to do our work better. So trying to do our best, and it went well, I think, for most of us. We tried everything. We learned from even the spring semester 1 year ago, and then we're going to follow probably coming back to this spring 2021. A lot of improvements, a lot of knowledge, and a lot of things that we're going to probably keep learning and using for the future. Thank you.
Pratap, can you give us a little roll up on your session?
Yes. Uh, um, so one of the universal opinion or the impression what the participants in my group had was there was a significantly higher amount of ignorance in the subject matter after the whole class was concluded. That is, in comparison, although we cannot compare the two things, but in the bottom line, how competent the students were, especially in the laboratory classes, in going through the COVID, there was a significant loss of learning in this whole process, which needs to be condoned in the following semesters in the upcoming 2021 fall. So one professor talked about how he dealt with a C++ programming class. So the problem they faced was none of them knew programming. And then it was one blind man trying to lead the another blind man. So they are not aware of the different constructs in the data structures in the programming language. What is a for loop? What is a do while loop? What is a real variable? What is this thing? And what they did was they assigned the responsibility to the group members, and then they figured out how to collaborate so that they could get the assignments done. And so fortunately it was a small group and they were able to do it. And this gave insight into what collaboration can do and what it cannot do. The another professor talked about how to handle the senior design project. There it was really a challenge, mainly because making different students at different locations to give ideas, and somebody else executing it and somebody else analyzing this, and how to communicate between them. And that was a difficult situation. And they came up with some new collaborative platform where they could communicate with each others and keep tabs, and make sure that not everybody is involved in the administrative part of the business, but on the technical part of the business, so that they could evaluate the contributions. So finally, some of the things they came up, and universally, some of the impressions was this COVID, although it looked bad, in the ultimate analysis, there is a lot of lessons which have been learned in this process. That is, what could be done remotely without the person-to-person interaction in the most effective manner, and what cannot be done in a remote fashion without losing what they call it as the devil is in the details. So you may find that they have already submitted the report, but what kind of a report is it? Have they really understand the concept? So there is a lot of masquerading the actual facts under the guise that they have already understood, because there is nobody to check it. So the intrinsic problem of checking and making sure that they have understood what they are supposed to understand was a major challenge which has to be addressed in the oncoming classes in the fall, because this has got very serious implication in the industry, since they will only have bosses who are going to assign them responsibilities and expect the results. So in the whole in the conclusive fashion, if I could say, is it really taught a lot of lessons and gave a lot of insights, and saw that this is a very difficult situation, especially in a practicing profession like engineering. And we need to really lay stress on where the cracks are in the learning process, because today's students are going to be tomorrow's engineers and leaders in the profession, and we don't want them to carry this confusion all along their higher classes and come up with some erroneous situations. Thank you.
Thank you, Pratap. Alan.
So We had a lot of different discussions about how do we make sure the students actually learn in lab. Some teachers had, sort of forced the students to be present or remote and to keep those number of sessions equal, sort of to force the students to learn how to operate the equipment. Some faculty were giving their, at the end of the lab, a practicum where each student was tested and had to do one of 10 problems. And I thought that was great, but time consuming if each problem requires half an hour for each student. Several people talked about how there's an advantage of people being remote and that forced everyone to learn, making the students do their own debugging. And they said, like, in normal times, there oftentimes is a alpha male, which sounds sexist, but I think has a fair amount of truth to it, who kind of just takes over and runs the lab, assigns roles, and that kind of disappears in the remote situation. We had a discussion about are measurements still necessary, since you can just buy modules and hook the modules together. And Mario pointed out that someone's designing those modules. We had was raised that in the early days, students could be just electrical engineers or computer engineers, but now students are at a disadvantage unless they're really electrical and computer engineers. That both are needed. And then we just had great general discussions about other education. So it was lovely. Thank you.
Thank you, Alan. Was anybody in on Leslie's side room, breakout room, that could give us some 2 cents on what they had? I think there was only 3 groups that actually was able to cycle through there. If anybody can jump in and give us some insight.
How are the cupcakes?
I didn't get one. I'm just going to have to take a drive to the other side of the river and just pick one up.
Well, if nobody was there, but I can tell you from every day talking to Leslie what it potentially was, okay? And she keeps on reminding me that no matter how much we try to bridge the gap between the haves and have-nots, both by knowledge base they have had from their schools and from the technology infrastructure they may have, it's a challenge. And we want to have everybody's voice heard. We are inclusive. We want to get more folks involved, but it can't be equal until everybody has the same base. And I think we've struggled with it in freshman year a lot. You can have an incoming freshman with 9 APs and somebody who's come from a school where there are no APs, So both are equally brilliant, but both may just have the disadvantage because of the system that they belong to. And that's enough to discourage somebody, because we all like to be, as engineers, grade on curve. And that's really not fair, because we are actually asking somebody who's better to perform better forever. So I think that level of inclusiveness is critical in engineering, because we are so meritocracy focused. So anyway, and she reminds us every day about this.
Thank you, Sid. Some high level things that I have as a takeaway, and anybody wants to jump in, go right ahead. We are humans, and humans are social creatures. This past year and a half is just 180 degrees out of phase with who we are. We need physical interaction with each other. So working in isolation puts a tax on us mentally, which I have seen get in the way of some of the learning. The other side of the coin is y'all got to learn to be, autodidactic, because after you leave school, your learning doesn't stop. And I think it's our job within academia to push the kids out of the nest, as I said earlier, and learn to fly on your own. How do you learn? You graduate, your learning doesn't stop. So figure out how things work. And when you get a job, your boss knows that you don't know everything, but your boss is going to assume that you know how to learn things. What we are learning now in school, and somebody brought up in one of the groups there, some parent asked, what kind of job is my kid going to have when they graduate? That job may not exist yet. All right. So you have to learn to adapt. And I think we have to get out of the comfort zone. Our comfort zone in academia, K to 12, and we in post-secondary are in a good position to get these kids to say, hey, you don't need to be in the classroom anymore. So we should be the support structure for them. Kick them out of the nest, learn on your own. You got questions, come back and ask us. We can help guide you through that. We have to build their confidence. I don't think they have the confidence to learn on their own. And it's not until you spread your wings and fly that you will build that up. So anybody else have we got like 4 minutes left here. Anybody else have anything they want to add real quick?
Mario, I just throw in something that has nothing directly to do with this meeting, but relates to what you just said about lifelong learning and being able to learn when you get pushed out of the nest. I've been connecting with two of my former students who have fairly high positions, one at IBM and one at Comcast. So my former student, who is actually the head engineer at Comcast, he just put every single person who works for him through a Python course, every single one, because of this issue of being able to stay on top of both the hardware and the software. A lot of them were traditional electrical engineers and had learned to program previously, but weren't up to date on Python, and they needed a common language that everybody was using. And then the guy at IBM is his area is in fact making sure that he works basically as an individual consultant for people in the cloud computing area, and they've arranged for the bringing people's skill sets up, upskilling people in the basics of cloud computing. That's 25,000 people at IBM had to do that. So these are the things that we somehow or other have to integrate that sort of activity. What exactly they're doing, I think we need to maybe think about giving our students credit for doing some of these certification things or whatever it might be that they're going to be doing while they are working. And it's the kind of thing that people will value when they're looking at somebody as the first, an entry-level employee. But by doing that, they're going to learn how to do it. That's the thing. We're giving them this educational experience that is very different from what they're going to get on the job. And I think we need to integrate some of these things that they're going to do on the job. We have to make sure it's not just learning to be a mechanic, which is actually a lot of certifications are, that you're learning how to operate a particular piece of equipment and that's all you get out of it. But if we do that in the context of the broader learning that we expect of students getting a BS in EE or ECE or CE, I think this can be an incredibly valuable experience for students. It's just a thought that came up kind of over the last couple of weeks of talking to people like this.
If I could chime in, we're about to transition into lifelong learning, which is what we're already discussing and what was discussed in a lot of these groups. And I do think it is fascinating. I'm going to pick on my wife again. She's also a CPA, and every year she has to do 32 hours of study in order to keep her certification. And 32 hours would be meaningless, I think, in our profession. I mean, if you're not constantly updating your skills and learning the newest technology and playing with the newest toys, you'd be washed out of school or washed out of your job. So I do think it is a very important topic for us because we are in evolution every time we pull out a soldering iron or open a book or anything.
I agree. I agree, Hayne. You know, this lifelong learning, and what Ken brought up is true. I mean, I learned C programming from one of my employers. I mean, we were doing assembly language program, and then they said, hey, you know, there's a better way of doing this. And they brought the entire engineering department up at one time. They hired a consultant to come in to teach us. And that's great if you have a progressive company that does that, but that doesn't mean you as a self-learner can't learn it on your own. And I think that's part of the thing that we need to instill in our students is, and I think Sid brought something up about, you know, we need to applaud students that learn outside of the classroom. Okay, make
Yes.
them lifelong learners. So thank you everyone that participated. Thank you to all of our panelists. Thank you to all of our staff at ACETA for helping to put this thing together. And I'm going to turn the show back over to Hayne.